Hello and welcome to Star Optics Academy. In today's video, we'll be looking at an introduction to organic compound. Before we dive into the main aspects of organic compounds, let's first of all look at what organic chemistry is. Organic chemistry is the study of hydrocarbons and its derivatives. When it comes to the study of organic chemistry, the priority is given to carbon. That is to say that carbon is the main element when it comes to the study of organic chemistry. There are three main reasons why carbon is so important in the study of organic chemistry. Number one reason is that the ability of carbon to catenate. The ability of carbon to catenate makes it so important in the study of organic chemistry. When I say catenate, I mean the ability of carbon to form single bond, double bond, and triple bond with its own atom or atoms of other elements. So, number one reason why carbon is so important in the study of organic chemistry is the ability of carbon to catenate. So, secondly, the second reason why carbon is so important in the study of organic chemistry is its ability to use its tetravalency, its ability to use its tetravalency to combine with its own atom or atoms of other elements. When I say its tetravalency, I mean its ability to form four bonds. Does that mean carbon is the only element that can form four bonds? No. Other elements on the periodic table, carbon is found in group 4, second period in the periodic table. If we try to look at the periodic table, you will see that on group 4, we have other elements such as silicon, germanium. But carbon is so special to the point that the covalent bond between carbon atoms are so strong compared to other elements like silicon and germanium, which are also found on group 4. So the ability of carbon to form tetravalency, to use its tetravalency to combine with its atom or atoms of other elements is what makes it special in the study of organic chemistry. The third reason why carbon is so important in the study of organic chemistry is the ability of carbon to form straight chain, ring chain, and branch chain. So in summary, organic compounds are compounds of carbon atoms. So organic compounds are classified into two. Number one classification of organic compounds is hydrocarbons. The second classification of organic compounds is non-hydrocarbons. Hydrocarbons are compounds that contain hydrogen and carbon only, while non-hydrocarbons contains carbon, hydrogen, and other elements. Non-hydrocarbons are derivatives of hydrocarbons. They are formed by replacing one hydrogen with elements such as oxygen, nitrogen, or sulfur. So, Apart from hydrocarbons having just carbon and hydrogen as its atom, non-hydrocarbons contains other atoms such as oxygen, nitrogen, and sulfur. Hydrocarbons are subdivided into two. We have aliphatic and aromatic. A very good example of an aromatic compound is benzene. Others include naphthalene and triazine, but a common example of aromatic compound is benzene. Aliphatic compounds are compounds that are, let's say, examples of aliphatic compounds are alkanes, alkenes, alkynes. They are the most common examples of aliphatic compounds, while the most common example of aromatic compound is benzene. Aliphatic compounds here is subdivided into two. We have cyclic and acyclic compounds. So apart from it being aliphatic, it can be cyclic or acyclic. When I say cyclic, it can be in a ring form. It can be in a ring form. Then the acyclic compounds are the ones that are either having the straight chain or the branch chain. So the aliphatic compounds could be cyclic or acyclic. So they can form ring, straight chain, or branch chain. And while we're discussing the properties of carbon, why carbon is so important in the study of organic chemistry, we said carbon is so important because for another reason, it can form straight chain, ring chain, or branch chain with its atom or atoms of other elements. So non-hydrocarbons here could be acidic. They could also be basic. And they can be neutral also. So a very good example of non-hydrocarbon that is acidic is alkanoic acid. A very good example of a hydrocarbon that is acidic is alkanoic acid. So, with all this said, let's look at some common terms that are used in the study of organic chemistry. Before we go deeper into the study of organic chemistry, let's first of all understand some common terms that can be used in the study of organic chemistry. Let's look at some common terms used in the study of organic chemistry. Number one, we have homologous series. Homologous series Homologous series are a family of organic compounds that are homologous series are a family of organic compounds in which successive members differ from the previous by a CH2. So let's say a family of organic compounds can have a particular number of atoms. So the difference between a homology with another is by CH2. So let's say Some common examples of homologous series that we know is, let's say, alkanes are a family of organic compounds, and then let's say alkenes also. These are two different family of organic compounds. So let's say the members of alkane will differ from the other with CH2. So in simple terms, with the addition of CH2 to a homology, you get the next homology. So with the removal of CH2 from a homology, you will get the previous one. Let's, for instance, say the first member of alkane family is methane. With this formula CH4. So with the addition of CH2, you have another member of alkane family, which is ethane. So let's say with the addition of CH2 to this, we are going to have 1 plus 1 carbon, which is 2 carbons, and then 2 hydrogen, which is 4. 2 plus 4, which is going to give us 6. So with the addition of CH2 to the formula of methane, we are going to get ethane because the homologous series differs from the other with CH2. And addition could lead to getting the next, while a removal of CH2 will lead to getting the previous one. Let's say we add CH2 to this evening, we are going to have C3H8. So this will give us the third member of the alkane family, which is propane. Same thing applies to alkenes, for instance. The first member of alkane is ethene. So the molecular formula of ethene is C2H4. So the addition of CH2 to C2H4 will give us the third member, the second member of the alkene family, which is propene. The second member, which is propane, and with the addition of CH2 to this, we are going to obtain C3H6. So with the addition of CH2 to this, we are going to get the third member, which is butane, and with the addition of CH2 to this, we are going to have C4H8. So in summary, for you to understand organic compounds, you have to have a very good idea of homologous series. You will know what differs between the previous and then the next. So, in summary, homologous series are a family of organic compounds in which successive members differs from the previous by CH2. You can say let's say propane, for instance, will differ from ethane by CH2. These are two different families of organic compounds. This belongs to the alkane family, while this belongs to the alkene family. So these are two different families of organic compounds. You can't say alkane and alkenes are the same. They are different. For instance, alkane contains single bond throughout, while another difference is that this contains double bond. So that's all about homologous series. The next common term we'll be looking at in the study of organic chemistry is alkyl groups. Another common term that we'll be looking at in the study of organic chemistry is alkyl groups. So alkyl groups are a family of organic compounds that are derived from alkanes, with the loss of one hydrogen atom. So let's say for alkanes, their corresponding ending is ANA. So with the removal of one hydrogen from a member of the alkane family, we are going to get the alkene family, or you can also call it the alkyl family. So with the removal of one hydrogen from the alkanes family, we are going to get a member of the alkyl family. Let's take, for instance, methane. And the formula for methane is CH4. So with the removal of one hydrogen from methane, you are going to get methyl. And the molecular formula will be CH3. Why? Because you are removing one hydrogen to get the methyl group. Let's take another member of the alkane family, which is ethane, with the molecular formula C2H6. So with the removal of one hydrogen atom from ethane, you're going to get ethyl, with the molecular formula C2H5. So the only difference between the alkane family and the alkyl family is one hydrogen atom. That is to say that with the removal of one hydrogen atom from the alkane family, you're going to get the alkyl family. The third common term we'll be looking at in the study of organic compounds is bonds. Organic compounds are joined together by covalent bonds. Organic compounds are joined together by covalent bonds. So what are covalent bonds? Covalent bonds are bonds found between atoms, which is due to sharing of electrons. The bond found between organic compounds is known as covalent bonds. Covalent bond. And it is formed as a result of sharing of electrons between the corresponding atoms. Let's say, for instance, carbon is combining with hydrogen. This type of bond here is known as a covalent bond, and it is formed as a result of sharing one electron from hydrogen and one lone pair of electrons from carbon. That is to say that the covalent bond found in organic compounds contain. So let's say, for instance, carbon is bonded to 4 hydrogen. Let's say, for instance, carbon is bonded to 4 hydrogen. On this particular bond here, there is one lone pair of electron from carbon and one from hydrogen. Same happens here and here, here and here, here and here. That is to say that in each bond, there are 2 lone pairs of electrons. And as a result of that, if carbon will form 4 bonds, that means there are 8 there are 4 lone pairs of electrons. That is, one bond contains 1 lone pair, the other contains 1 lone pair, the other contains 1 lone pair. And when you say pair, it means 2. So each contains 1 lone pair, And with the combination of the 4, we have 4 lone pairs of electrons. That is 5. That's to say that we have 8 lone electrons when carbons combine with 4 hydrogen. Let's see. So the bond found in organic compounds can either be a sigma bond or it can be a pi bond. Please take note of this. When an organic compound, or let's say when carbon is combining with itself, and then there is a single bond, the single bond formed between carbon atom or carbon and other atoms is known as a sigma bond. If carbon is combining with itself or other elements, let's say carbon is combining with itself with 2 bonds, there is 1 sigma bond and 1 pi bond. When carbon is combining with itself with 3 bonds, there is 1 sigma bond and 1 pi bond. So in summary, organic compounds with containing single bond have 1 sigma bond. If organic compounds contains 2 double bonds, we have 1 sigma and 1 pi. So if organic compounds contain 3 bonds, we have 1 sigma and 2 pi. So that is all for bonds. The next we'll be looking at is hybridization. Hybridization is the mixing together of 2 or more orbitals of the same energy level to obtain a new set of orbitals which has the same energy as the mixed orbitals. Let's say, for instance, or let's say, what is an orbital? Orbital. The region of space where electrons are likely found in an atom is what we refer to as an orbital. So, if the region of space where electrons are likely found is known as an orbital, then the mixing of one orbital with the other is known as hybridization. So, it's just like you mixing 2 things to get one another stuff that looks exactly as that stuff that you have mixed. If, for instance, you mix, let's say, an orange drink that has the same color as Fanta, there will be no color difference because you have mixed what contains the same thing. So in hybridization, it is the mixing of 2 or more orbitals, and these orbitals being mixed contain the same energy. So as they contain the same energy and they are mixed together, there is no change between the new orbital that has been formed. The new orbital formed is known as a hybrid orbital. So there is no difference between the hybrid orbital and the 2 sets of orbitals that join together to give the hybrid orbital. In organic chemistry, there are 3 main types of orbitals, of hybrid orbitals. We have the sp orbital, the sp2 orbital, and the sp3 orbital. The sp orbital is formed when there is a transfer of 1 electron from an s sphere to the first p orbital. P has three orbitals, px, py, and pz. So the transfer of electrons from s to px is what is known as sp hybrid orbitals. And then the transfer of electrons from the s to the py, which is the second orbital of the p subshell, is known as the sp2 hybridization. So the transfer of s to the third p orbital is known as the sp3 hybridization. So the next term we'll be looking at in the study of organic compounds is saturated and unsaturated hydrocarbons. Organic chemistry, organic compounds containing single bonds are said to be saturated, for instance, alkanes. Meanwhile, the organic compounds that contain double or triple bonds are said to be unsaturated. For instance, alkenes and alkynes. So in summary, alkanes are saturated. Main reason, they contain single bond throughout, while alkenes and alkynes are unsaturated because they contain double bond in alkenes and triple bonds in alkynes. So the next term we'll be looking at in the study of organic compounds is isomerism. And then lastly, we'll look at functional groups. Isomerism is a phenomenon whereby compounds or atoms exhibit the same molecular formula but different structures. A phenomenon whereby atoms or compounds exhibit the same molecular formula but different structures is what we refer to as isomerism. And the atoms or the compounds forms are known as isomers. For instance, let's say we have C4H10. This is butane. Let's draw the structure of the two possible structures of this. The longest continuous carbon chain being 4, and then we have 10 hydrogen atoms, 3 forming here because carbon cannot form more than 4 bonds. 2 hydrogen will be here, 2 will be here, and lastly 3 will be here. So, okay, let's say this cannot give us isomers. Let's say we have C5H12. So this can give us 2 possible isomers. And then we'll have under CH3 here. 1 hydrogen here, 3 hydrogen, 2 hydrogen, and 3 hydrogen. This has the same molecular formula but different structures. So when compounds contain the same molecular formula but different structures are known as isomers. For instance, we have 5 hydrogen, 5 carbon, and then 12 5 carbon and 12 hydrogen. Here we have the same thing, 5 hydrogen and 5 carbon and 12 hydrogen. And the name of this compound is pentane. why the name of this particular compound is 2-methyl butane. So these are two different compounds with the same molecular formula but different structures. So these are isomers. Lastly, we'll be looking at functional groups. Functional groups are a group of organic compounds that have a common atom or a radical or a bond within them. Let's say functional groups are a group of organic compounds in which there could be a bond common between the homologous series or a radical. When I say a radical, I mean a group of atoms or let's say a bond, a radical, or a group of atoms that could be common between the homologous series. Let's take, for instance, alkanes. The main difference between alkane and other homologous series is their carbon-carbon single bond. Meanwhile, the main difference between alkenes and alkanes is their double bond, while alkynes, the main difference between them and other compounds is their triple bonds. So, functional groups are a group of atoms, or let's say they are a group of organic compounds that have a common bond or radical between the atoms, or let's say a group of atoms as in alkanoic acid. What differentiates alkanoic acids from other functional groups is their 2 oxygen and 1 hydrogen. Same thing applies to esters, for instance. What differentiates esters from other functional groups is also their 2 hydrogen, but a combination, how these 2 atoms combine with this particular hydrogen is different from how, let's say, how this combines with the carbon and how this combines with its carbon is different from this. So what is common between this is, let's say for this, the carbon is bonded at the end, double bonded with oxygen and with oxygen, and then the oxygen bonding with H. So for this, you have the carbon bonding with another alkyl group. So with all of this said, we have come to the end of this class. Please, if you find this video helpful, please consider liking and subscribing to this channel. Thank you so much for watching. Just started, you guys, huh?